How does your TV remote control communicate with your television? How is heat detected? Interesting, isn't it? For those curious minds out there, the answer lies in the realm of infrared technology. These are questions that often pique our curiosity and lead us down the rabbit hole of scientific exploration. Infrared technology is a fascinating field that has revolutionized many aspects of our lives, from remote controls to security systems, and even to detecting heat. One of the key components of this technology is the infrared detector, which comes in two types: single frequency and multi-spectrum. Today, we'll be focusing on the single frequency IR detector, a device that is sensitive to a narrow band of radiation and plays a crucial role in detecting hydrocarbon-fueled fires. This unassuming piece of technology is more prevalent and important in our lives than we might realize. So fasten your seatbelts as we journey into the fascinating world of single-frequency IR detectors. Stay tuned. So, what makes single-frequency IR detectors tick? Let's dig into their working principle. At the heart of single-frequency IR detectors is their sensitivity to a narrow band of radiation. This band is typically around the 4.4 micron range. Why this particular range, you may ask? Well, it's no random choice. This is a predominant emission band for fires fueled by hydrocarbons, the primary component of many common fuels. Now here's where it gets interesting. The sun's radiation at this band is absorbed by the Earth's atmosphere. This makes the IR detector solar blind, meaning it isn't affected by sunlight. This feature is a significant advantage as it helps avoid false alarms during daylight hours. The key component of these detectors is the pyroelectric sensor. Pyroelectricity is the ability of certain materials to generate an electrical charge in response to a change in temperature. In the case of our detector, it responds to changes in infrared radiation intensity. But how does the detector distinguish between a real fire and other sources of infrared radiation? That's where the low-frequency bandpass filter comes in. This filter limits the detector's response to frequencies that are characteristic of a flickering fire. It's like the detector's very own bouncer, only letting in the frequencies that belong to the exclusive fire club. Once the sensor picks up a fire signal, the electronic circuitry inside the detector swings into action. It processes the signal and generates an output, which can then trigger an alarm or activate a fire suppression system. In essence, the working principle of single-frequency IR detectors is a clever combination of sensitivity to a specific radiation band, the use of a pyroelectric sensor, and the application of a low-frequency bandpass filter. This combination allows these detectors to accurately and reliably detect fires while minimizing the risk of false alarms. With this knowledge, we can now explore what makes these detectors both efficient and unique. Now that we understand how they work, let's discuss why single-frequency IR detectors are so important. Single-frequency IR detectors offer several significant advantages that make them invaluable in certain scenarios. For starters, these detectors are sensitive to a narrow band of radiation around the 4.4 micron range. This range is a predominant emission band for hydrocarbon-fueled fires. This means that single-frequency IR detectors are incredibly effective at detecting fires fueled by substances like oil, gas, and coal, among others. Another advantage of these detectors is their solar blindness. This feature is due to the sun's radiation at this band being absorbed by the Earth's atmosphere. This means that the detectors won't give false alarms due to sunlight. They focus solely on the radiation frequencies given off by fires. This specificity makes them incredibly reliable. Now, let's delve into some of their practical applications. Single-frequency IR detectors play a crucial role in industries where hydrocarbon-fueled fires are a risk. They are widely used in oil and gas industries, petrochemical plants, and power generation facilities. These detectors provide the first line of defense in these high-risk environments, raising the alarm at the first sign of a fire, potentially saving lives and preventing catastrophic damage. Additionally, these detectors are also used in commercial settings like shopping centers and office buildings, where they provide an extra layer of fire safety. They can also be found in transportation, including both public transit systems and private vehicles. Moreover, they are used in forest fire detection systems. These systems use single-frequency IR detectors to monitor large areas of forest for any signs of fire. When a fire is detected, the system can alert authorities quickly, helping to prevent the fire from spreading. In the world of research and development, these detectors help scientists study phenomena like climate change and atmospheric pollution. They are used in satellites to monitor the Earth's atmosphere and provide valuable data to scientists and policymakers. But like all things, these detectors have their limitations too. While single-frequency IR detectors are impressive, they do come with some limitations. Let's delve into these. One key limitation is their general unsuitability for non-carbon fires. This is because single-frequency detectors are primarily sensitive to a narrow band of radiation around the 4.4 micron range, a predominant emission band for hydrocarbon-fueled fires. Thus, they may not effectively detect fires fueled by substances other than hydrocarbons. Additionally, single-frequency IR detectors may respond to modulated infrared sources. This means that certain light sources that fluctuate in intensity could potentially trigger a false alarm. This can be a problem in environments where such light sources are common. Environmental factors also play a part in the performance of these detectors. Rain, ice, and water vapor on the detector lens can inhibit detection. This is due to the fact that these elements can either absorb or scatter the infrared radiation, preventing it from reaching the detector. This could be a significant issue in outdoor settings or in environments with high humidity. These limitations should not discourage us from appreciating the value of single-frequency IR detectors. It's important to remember that no technology is perfect, and each comes with its own set of challenges. Despite these limitations, single-frequency IR detectors continue to play an essential role in our lives. Infrared technology, specifically single-frequency IR detectors, is an intriguing field, isn't it? We've dived into how these detectors operate, honing in on a narrow band of radiation. Their unique sensitivity to hydrocarbon-fueled fires and solar blindness makes them quite remarkable. However, we also touched on their limitations, such as unsuitability for non-carbon fires and susceptibility to environmental factors. We hope this video has shed some light on the fascinating world of single-frequency IR detectors. Stay curious and keep exploring.